Hello, I'm here helping a student today, and we are going to spend some time going over the quiz number 2 over factoring. And so this will be the answer key. So if you were wondering, where you made a mistake, this should help guide you. So the first thing that we're always going to do is look for that greatest common factor. Now, a lot of times there won't be anything besides a 1, and that's okay. But it's important to acknowledge that in case there is something that you can pull out. So the only thing that is in common between these 3 terms is a 1. The first 2 terms have an X, but the third term does not. And then a 1 here, right? An unsaid 1, 11, and 12 have no other common factors. So the second question we always ask ourselves is, how many terms do we have? So we have 3 terms. And if we go to our factoring flow chart, I don't know if you have that with you, Nathan. Try to get to mine. In just a minute. Okay, so we go to our factoring flow chart and we ask ourselves, what are the possibilities for 3 terms? So we said, no, there's no other common factor. How many terms? There's 3 terms. And so my only option are going to be 2 binomials. So like it might look like something like this right here, x minus 7 and x plus 3. That's kind of what we're envisioning, because the only way to make an x squared is an x times an x. So we're thinking about using our FOIL multiplication system in reverse. So we're envisioning that we've got something like, I'm just making something up here. We're envisioning that we've got something like this, and we're going to multiply using our FOIL, our first, outside, insides, and last. So the x times x would make the x squared. And then when I distribute this x here, I get a minus 3x. And then I'm going to distribute my 2 to the other binomial. I have a positive 2x, and distribute my 2, and I have a minus 6. And so that's what makes the x squared. And then my middle terms will usually, not always, but usually be like terms that I can add. So x squared, and then a minus x, and then a minus 6. So the idea is that when we're factoring, we're looking at this thing we're starting with, and we're like, oh, I'm looking for things that multiply to make a negative 6. And it happened to be 2 and negative 3. And at the same time, those 2 values add to make the number in the middle term. Okay, and so that's what we're doing back on this one. I'm looking for factors of a negative 12, which add to make the middle term, which in our in a quadratic we call this ax squared plus bx plus c. So we're looking for numbers that add to make the b, which in our case is a negative 11. Okay, and so I know that to make 2 numbers multiply to make a negative, 1 has to be positive, 1 has to be negative. So I'm just going to list all of my pairs. They have to be 2 numbers, pairs that multiply to make a negative 12. So I have a negative 1 and a positive 12, a positive 1 and a negative 12. Then I've got 2 and a negative 6, a negative 2 and 6, a negative 3 and 4, and a 3 and a negative 4. And then I've got the flip-flop, right? With me so far?
Yep.
Okay. And then I'm going to just take my list and I'm going to add those numbers together. So I get a positive 11, a negative 11, a negative 6, a negative 4, a positive 4, positive 1, and a negative 1. And the magic 1 is the one that added to a negative 11. So this is the pair of numbers that I'm working with. And so that these can go either way. So we could either say x plus 1 minus 12, or we could say x minus 12, x plus 1. So when I multiply them, I just kind of double check. When I multiply these, I get a negative 12. And when I add them, I get a negative 11. Do the thumbs up on that one?
Yep.
Okay.
That makes a lot more sense.
Okay. And so, and there's a lot more on my factoring videos that I have. So you can always go back, and then in my Math 104 YouTube playlist, you can always go back, and I think it's 1.6 and 1.7. I have a lot of videos too. So, so then now on the next one, it's GCF. That's why I always ask this, is just a 1. And our second thing is the number of terms. We have 3. And so again, the only thing I could have are these 2 binomials. And it's nice because A is just a 1, so I can only possibly have an X and an X to make X squared. So I'm looking for factors of 12 again, not negative 12, but just a positive 12. So it's going to be a similar list to what I had up here, right? 1 and 12. But to make a positive 12, I could have 2 negatives, right? My numbers could both be positive or both be negative. So that changes it up slightly. So negative 2 and negative 6, 3 and 4, negative 3 and negative 4. And then they need to add this time to make a negative 7. And so I've got 11 and 13, I mean, a negative 13, 8, a negative 8, 7, and a negative 7. So this time the magic pair is this pair right here of X minus 3, X minus 4. We're good so far?
Yeah.
Okay. Now,
So why is the greatest common factor a 1?
because I don't have any X's in this last term, right? If I'm just looking at these 3 terms,
Yeah.
and then the coefficient on X squared is just a 1. And so 1 and
Yeah.
a negative 7 and 12, the only thing they share in common as factors is just a 1, because 7 is prime. Yeah.
Okay.
Yep. And so you'll see on my my videos, there's ones where there is a common factor that comes out. It's just, I'm trying to just do some basic ones just to keep everybody going and factoring, and then I'll probably maybe do like a trickier one here in a couple weeks on factoring. So
Okay.
then this one, again, it just happens to be my greatest common factor is a 1, because 25 only has factors of 5 and 5 and 1, and 16 doesn't have any 5s as factors, so they don't share anything in common. This time though, I only have 2 terms. So this is where I get out my handy dandy factoring flow chart that I have that you can print. You can click on that link in the modules, and if you want me to mail you one, I can do that. So if I go over here to where there's 2 terms, these are my only possibilities. I have 3 possibilities. It could be a difference of squares, and that only works if I have something squared minus something squared. So I'm just going to look for a minute, and it looks like I have squared things, right? This X squared. So that's going to be my only possibility if it works, because the other 2 under the 2 term possibilities are cubes. This one's a cube and this one's a cube. So I know those aren't even a possibility. So if this works, I got to have something squared minus something squared. And I know that 25 is 5 squared. So this is really 5x, that thing squared, minus 4 squared. So on this one, there's no middle term. It's only 2 terms. So that means when I multiply them together, on my example at the beginning of our little session, they had like terms that added together. Well, what's unique about this is that there's not a middle term. So that means they must have added to 0. So there must have been a plus and a minus of the same thing that added to 0. And so that's why we know that we factor these into what we call conjugates. 5x minus 4 and 5x plus 4. So you'd multiply and get a negative 20x and a positive 20x, and those middle terms add to 0. And then we get 25x squared on the front and negative 16 on the back. Okay, so that's the only possibility for 2 terms when it's a square. Okay, now we're down to the next one. So question number 4. So again, we only have a greatest common factor of 1, and we have 2 terms. But I'm taking notice that I have something cubed. So on my factoring flow chart, I've got, it's not the squared because that's not a possibility this time, but it could be something cubed or something cubed. One possibility is when there's a subtraction and one is an addition, and it looks like we have a subtraction. So if we can make it into this form here, we can just use this like recipe basically and fill this in. So if we can make it into something cubed minus something cubed, we can use this. So let's see if we can get that set up. Now, if you're not sure if 8 can be a perfect cube of something, you can always check this in Desmos. And I'm just going to show so that anybody that's watching the video can see how I would do this in Desmos. So in Desmos, I would go, well, I'm just going to make a table 1. And my shift and my 6 key gives me an exponent. So I can say cubed, that's just 1. And then I'm going to do 2 cubed. Oop, that's 8. Okay, so I know I can make 2 cubed can make 8. And then you could do anything you want. 4 cubed, you could keep checking them and see if you get, to a cube. So I know that 2 cubed makes 8. So that's fabulous. Let's just go here. So I know that this can be 2x, the whole thing cubed. And the great thing about 1 is 1 cubed is just 1. So now I have my recipe set up. I have something cubed minus something cubed. So my first something in my pattern, I'm going to call that A will be the 2x and the B will be the 1. So I'm just going to write down again what the pattern is, and then I'm going to fill it out for us. So the pattern from my factoring flow chart is A cubed minus B cubed factors into A minus B times A squared plus A times B plus B squared. So now that A equals 2x, I can replace A with 2x in each of these spots. So I've got 2x minus, and B is just 1. And then here, this is A squared. So I'm just going to write 2x squared. I'll simplify that in a minute. Plus A times B. So that's just 2x times 1 plus B squared. So 1 squared. Do you see how I filled that out? Okay. And so this is just 2x minus 1. And then we've got 4x squared plus 2x plus 1. Now, these difference of cubes, we're not going to use them a lot in our class. I'm sure Mr. The other teachers might, different how they test with their factoring and such like that. But you would probably really not use this again until maybe later on in Math 151 a little bit. But if you were going to take a calculus sequence. So you're really kind of just learning this just to understand factoring. But the factoring that we've done up here, and then the first 2 problems are factoring that you would use a lot. And we're going to use again in 104 when we get to chapter 7. And a little bit in chapter 5 as well. Okay. And then the last problem is, okay, we're going to look for our greatest common factor like we always do. And it looks like, I don't think there's anything in common because we've got B's here, but not here. We've got X's in both of these, but not here. And then 1, 3, 4, and 12 do not share a common factor between everybody. So it's just 1. Then this was a unique one because there's 4 terms. So when there's 4 terms, I'm getting out my factoring flow chart that I use every single time. For 4 terms, there's going to be something called factor by grouping. And that means I'm going to take my first two terms and I'm going to factor out the greatest common factor. And then I'm going to factor out the greatest common factor between the second two terms. And so that's what I'm going to do here is I'm going to look at these first two terms and I'm going to see that they share an x in common. And so if I factor out the x, I have b plus 3 left over. And then I always can kind of check that and go, oh, if I distributed this back in, would I get b times x? Yep. And would I get 3x? Yep. Okay. Then I'm going to look at the second two terms and I'm going to ask myself the same thing. What do they have in common for a greatest common factor? And they share a factor of 4. So I'm going to make sure I put a sign for that. So that's a plus 4 that's going to factor out. And when I factor out of 4, I have a b left over. And then 12 and I factor or divide out of 4, I have a 3 left over. And then notice what I had left over in the first two was a b plus 3. And what I had left over in the second two was also a b plus 3. So that will, if that doesn't happen, then it can't be factored. Okay. And so now I'm like, oh, I can see in the big picture between this thing and this thing that they share a b plus 3. So I can pull out a b plus 3 and I have an x left over here. And then I have a plus 4 left over here. And so I still ended up with two binomials like I did in questions 1 and 2. It's just, I kind of got started a little bit different because I started off with this 4-term thing. Any questions in between there?
Nope.
Okay.